One more example you can check now. S is equals to c into e power x by c. Show that c into radius equals to s root of s square minus c square. So basically we have to find radius here. So radius rho equals to ds by d psi if the question is in terms of s. So s is equals to c into e power x by c is there. So because x is there, x variable is there, we have to differentiate with respect to x on both sides. So c into d by dx of e power x by c. So this will be derivative of e power x is e power x into x by c differentiating inner function. So c into e power x by c into 1 by c outside, derivative of x is 1. So this will be c and c cancelled, or you can do one thing without cancelling. Can we replace question into this one? This is 1. We'll replace this because the answer contains s values in it. So c into e power x by c is s into 1 by c is ds by dx. By seeing ds by dx, you have to immediately go through with this formula. Dx by ds is cos psi. So this is reverse of cos psi, reciprocal of cos psi. So this is cos psi equals to s by c. 1 by cos is secant. Secant psi equals to s by c. This implies we will get a function in terms of s now. C secant psi. Once we get s, now we can easily find radius. Previously also the question is in terms of s, but the question is not in terms of psi. So we need psi. For that we have to differentiate with respect to x, then cos or sin we have to substitute in it. Now we have to differentiate with respect to psi as we have done for first second problem, same thing. C into derivating this one with respect to psi. Secant x is secant x tan x into nothing, because that is we have to differentiate with respect to psi itself. Now in this one, secant, can we replace secant? We got secant psi equals to s by c. So you can substitute it. Tan, we don't have tan, so we have to tan, we have to convert in terms of its identity, root over secant square minus 1. So this is secant square psi minus 1. So s into root over, again secant we have, we can resubstitute it, s square by c square minus 1. Now some basic simplification you have to do. C square s square minus c square. So this is s by c into root over s square minus c square. So this is rho. So cross multiply this one. C into radius equals to s root of s square minus c square. So few questions will be given to you in this form by giving you s function. By seeing this radius rho symbol, immediately you have to get those things in your mind. Then you can go through differentiating with that functions. One more is there. For this you need to remember this function. S square is equals to x square plus y square ds square by, if I substitute t in the denominator, ds by dt whole square equals to dx by dt whole square plus dy by dt whole square. So what is ds by dt at the end? Square root of dx by dt whole square plus dy by dt whole square. So ds by dt, by saying this you have to implement dt square, then you can derive your formula, or you can go through with this formula. When the s function is given and the two variables are given to us, two functions, if two functions are given in terms of t parametric form, ds is involved, so we have to find same pattern of radius we have to follow. First variable is x is equals to a into e power t, and the second one is y is equals to a into e power t cos t. Differentiating with respect to t, a into d by dt of e power t, d by dt of y equals to a into d by dt of e power t cos t. Here e power x derivative is e power x. Here uv form, a into u derivative of v, cos is minus sine, plus v derivative of u. So we got this one as a into e power t, here a into e power t common, cos t, then negative sin t here. This is dy by dt, dx by dt. Find squares also, dx by dt whole square, a square e power t whole square is e power 2t, dy by dt whole square, a square e power 2t, these two will get squared, into cos t minus sin t whole square. So a square e power 2t into a square plus b square minus 2ab. Or we can have one more function, this is the wrong question actually. Here we have a into e power t into sin t is there. Sin t here, e power t into sin t, a common, uv form, u derivative of sin is cos plus v derivative of u. So we got this one as dx by dt equals to a into e power t cos t plus sin t. When we take square for this one, dx by dt whole square, a square you will get, e power square means 2t. Here if you take square, you have to take whole square. While squaring this, we will get these multiple square, then this bracket is also multiple, so you will get whole square for this one. Okay. Then we have to find ds by dt, so this formula. Before that we'll add and we'll write, or you can write this ds by dt equals to square root of first one square value, whatever you got, e power 2t into cos t plus sin t whole square, then plus dy by dt whole square, this value, a square e power 2t cos t minus sin t whole square. So this will be a square e power 2t common, cos t plus sin t whole square plus cos t minus sin t whole square. If you find anything of this form, a plus b whole square plus a minus b whole square is 2 times of a square plus b square. 2 times of cos square plus sin square is 2 into 1. So a square e power 2t into 2 times of cos square plus sin square. So 2 into 1. So you can conclude by writing this one as ds by dt equals to, out of root a square becomes a, this e power 2t out of root is e power t, this is 2 into 1, it will get becomes root 2.